The Undo Cave was discovered some 30 years ago, but it has never been excavated. It's divided into three sections: the entrance, the tunnel, and the pit. The cave has presented the researchers with some extreme archaeology, and over the last year, a lift and a cage had to be built so that the team could descend into the pit. It's estimated that there are over 3 meters of sediment at the bottom of the pit. This year's excavations will look at the first 30 centimeters. It takes 15 minutes to reach the bottom of the pit, and the bottom is cramped and difficult to work in. There is also a second chamber leading off, and it is here that the most important find to date was located.
Yes, it's why we have this other element which is not.
We have to date it, of course. We have to select one sample. Is the charcoal in it too? The front and the back have different goals. Originally, the front has the goal to do what we can call more traditional Paleolithic archaeology, whereas the back is more of a new and innovative way of looking at things, because we do not have things in layers, and it's not simple to excavate the pit, and therefore our focus is more on finding fossil material and ancient material, human hopefully, but also animal bones, carnivores, bears, etc., and doing ancient DNA as well as isotope analysis and perhaps dating this material. So it's a different goal. At the same time, we got expert speleologists from France coming particularly to analyze the formation processes of the cave, which is extremely complex. The cave formation processes are probably spanning as much as at least 300,000 years or longer, including periods where before the pit was formed, periods where there was river flowing through the cave, there's pebbles in some layers, there's like various flow stones, stalagmites, stalactites, collapse of the walls, collapse and reforming of new flowstone layers and so on. Today we took more than 10 flowstone samples. We knocked them off, we broke them, and we have to do uranium series and so on in different laboratories to get a date. And some of these flowstones are capping the archaeological layers. So in terms of understanding the flowstone, eventually help us to understand the archaeology. And eventually, when we understand the archaeology and the flowstones, eventually we'll be able to link the front to the back. So hopefully we'll be able to put it all together. But this is a complex story, because we have about 70 meters of corridor leading between the front to the back. It's a very long way with various formation processes and various flowstones, and it's not something that can be easily understood, and that's why we got the experts to help us with it.
Thanks to the support from the French geologist and speleologist, it is now clear how the caves were formed, but it's still not clear in which order this happened.
One of the incentives for the analysis, for the excavation, is ancient DNA, and of course we also hope to find human remains or fossils, but we have good reason to believe that the pit has exceptional preservation, and because of the very stable temperature and the karstic environment, and therefore we have and we will have more fantastically preserved animal bones. And if animal bones are well preserved, you can potentially do DNA for human or non-human remains, even extending back 60,000 years or even more, which you cannot normally do in regions of hot climate. And so we have a potential to extract, to excavate and find animal remains and immediately take them to the lab and do ancient DNA.
And we have compared the origin sources of this obsidian, and they are the same. And
obviously this is just the first season, and it's going to take several more years to get deeper and to open larger areas and to get a better understanding and date everything and study the climate and subsistence, etc. In the back, we also have some progress. We tested several areas at the back. We found another pit that is adjoins the main pit. We excavated the shelf of this pit, and we found again, some various bones, including medieval, but also some things that look more ancient, like Paleolithic, for example, goat and bear. And in the main pit we found more human bones, including a skull. And today I found a tooth, also in a sieving, human tooth. We don't know the age of it because it's mixed with what seems to be Bronze Age pottery. But some of the assemblage, so the animal bones or the bones, seems to get older as we go deeper. But we have to do a lot more because we only gone about 30 centimeters off the surface, and we believe we have at least 3 more meters, if not a lot more. We excavated the karstic pit, and this is very unusual. Actually, I don't really know of any other teams excavating a 45-meter or whatever depth pit because of the dangers and the logistics involved. So, I mean, if we went down with ropes, for example, it will take people a good hour to just to get down, and then an hour to go up, and then it's very slow process. We wouldn't be able to lift any sediments. So we had to build a manual elevator, and that took us over a year to get it together. And that's why actually last season we weren't even excavating because we were just making preparations. So we invested thousands of euros just to prepare this excavation. Whereas if it was a regular excavation, we'd be excavating already last year. So this is just the beginning. So we have human remains in the pit, we have animal remains, and we still don't understand how all this material ended up in the pit. Was it just thrown into the pit? Was it thrown after as discard after death of the animal, or were the human remains thrown there after death, or was it, I don't know, some kind of ritual activity, or just discard, or was it accidental fall? We don't really know it at the moment, so we have to really continue and excavate more. The collaboration works very well with UCC, obviously, and Ilia University, and of course with some collaborators from Haifa University and other universities in the UK, and so on and so forth. I mean, it works well. It's partly funded by University College Cork, partly funded by Science Foundation of Ireland, of course, and it's also partly funded by Johannes Gutenberg University in Mainz, which is doing the ancient DNA and is a collaborator on my European Research Council grant.
The Republic of Georgia is perhaps one of the richest areas of prehistory and archaeology in Europe. Neanderthals and early modern humans shared this environment and had done so for some tens of thousands of years. But for some reason, Neanderthals disappeared. It's thought that climate change, extinction by pathogens and parasites such as leprosy and TB, or even genocide, may have contributed to their disappearance.